Okay, so here is another example of a percent yield. In the statement, it says here we have phosphorus. It reacts with bromine to form phosphorus tribromide. So if you read this properly, it says that you have 35.0 grams of bromine to start, and then it reacts with phosphorus, and then after that, it produces 27.9 grams of phosphorus tribromide. Okay, so the question asks you what is the percent yield. So to do percent yield, you need two things. You need the actual and the theoretical. In this particular statement, it actually gives you the actual already because it states here that you received 27.9 grams of the product side. All right, so let's go ahead and attack this. The reaction is not written for you, so you do have to write out the reaction. So phosphorus plus bromine will produce phosphorus tribromide. So you should start with highlighting the stuff that's reactants and product side, and then the reaction looks like something like this. You have P for phosphorus, and then it reacts with bromine. And then I want to remind you that bromine is a diatomic, so therefore this should be Br2, not just Br. So it's important to recognize diatomics, otherwise it will cause you a lot of headaches when you balance reaction. Okay, so keep in mind Br2 is indicated because it is a diatomic, and then it produces phosphorus tribromide. So phosphorus is P, tri for 3, and then there's bromide, which is Br. All right, but you notice here the reaction is not balanced because over here you have 2Br. On the product side, you have 3Br. While the P's are balanced, the Brs are not. So you do have to balance this one, okay? So it's important, again, to make sure you write a balanced reaction before you do any sort of these problems, because you need the proper mole to mole ratio. All right, so let's go and balance this. There's 2Br and there's 3Br. So the common multiplier would be 6 here. So to make this a 6, you need the 3 in front of Br, and you need a 2 in front of phosphorus tribromide. But then putting a 2 in front of here makes 2P, but in this side there's only 1P. So we do need to put a 2 in front of the P on the reactant side as well. Okay, so it should look something like this. If you don't know how to balance reaction quickly, I encourage you pause the video and learn how to balance it, because it is crucial to the rest of the work. All right, so let's go ahead and do percent yield. To do percent yield, again, you need the actual and the theoretical. In this problem, it gives you the actual number of grams of the product that's produced, which is 27.9 grams of phosphorus tribromide. And so we need to find the theoretical. So to find theoretical, start with what you're given. In this case, you're given 35 grams of bromine. So start with that. So the first step, by the way, if you notice, I just took out phosphorus here because the question has nothing to do with phosphorus. So I like to clean up my reaction and just focus on the elements or reactant and products that are being involved in the problem. Okay. All right. So I will start with 35 grams of bromine. So here we have mass. We need to go from mass to mole. 35 grams of bromine on top over a sexy 1. Convert it to moles by doing molar mass. 1 mole of Br2. Okay, you got to take Br and you got to multiply by 2. And that should give you a molar mass of 159.8 grams ish. Okay. All right, simplify your calculator work. 35.0 times 1, and then divide it by 1 times 159.8, and you should get about 0.219 moles of Br2. And now that we know moles of Br2, we can find moles of phosphorus tribromide because we know the mole to mole ratio. The ratio here is 3 to 2. Again, the coefficient in front of a balanced reaction is extremely, extremely important. So make sure you learn how to balance reaction or brush up on before you attack these steps problem. All right. So next, we know moles of Br2. So we can go ahead and convert moles of Br2 to moles of phosphorus tribromide by doing mole to mole. And then so we carry the previous answer down, 0.219 moles. That's our starting point. And then now we got to go from moles of Br2 to moles of PBr3. Make sure you place the coefficients in the proper place. The ratio is a 3 to 2, which is in the balance reaction where my cursor is circling around. Okay, so for every 3 moles of Br2, you need 2 moles of PBr3. And that's where these numbers come from in the numerator and the denominator. All right, and you notice here moles of Br2 cancels out, and it only leaves us with moles of PBr3. So if you do your calculator work, you should get about 0.146 moles of PBr3. Well, you need to take this a step further, and that is to go from moles to grams, because the statement gives you grams of product. So now you have to figure out theoretically how much grams you should receive. Okay. All right. So we just take the previous answer from the last step and convert it from moles to mass, which is in grams in this particular problem, and then use the previous answer of 0.146 moles of PBr3 as your starting point, and then do molar mass here because you need to convert moles of PBr3 to mass of itself. Okay, moles of PBr3 is going to cancel out, and if you do calculator work correctly, you should get about 39.5 grams of PBr3. Again, it's important that you understand what you solve for and not just kind of memorize this stuff. Okay, I just found how much should have been produced. So if you gave me 35 grams of bromine in this particular reaction, I should expect to get 39.5 grams of PBr3. So this is what I should be getting, which implies that this is the theoretical value. Should, theoretical, same thing. However, the problem sets that you didn't get 39.5 grams of PBr3. You did the reaction and you measure your product and you only get 27.9 grams, which means you didn't get what you expect. Okay, so to do a percent yield, all you have to do is apply the function here. So percent yield is what you actually get during a chemical reaction versus theoretically or ideal. All right. So in this case, the 27.9 grams given in the original statement represents what was formed during the reaction. So that's how much you actually got. So therefore, that goes to the numerator. And then I just found the theoretical 39.5 grams here of PBr3, where I'm circling, is what I should be, is what I should have gotten, but I didn't. Okay. So that's pretty much it. So all you have to do is find an actual value, calculate your theoretical, and then literally just do a fraction. So actual over theoretical. So if you do it properly, the values of 27.9 grams go in the numerator, and then the 39.5 grams of PBr3 goes in the denominator, and you would multiply by 100% because this fraction will give you a decimal, and then to convert decimal to percent, you would have to multiply by 100. All right, if you do that properly, you should get about 70.6 percent as your percent yield. Okay, I hope that helps. All right, other than that, that's it for that one. Stay nerdy, don't be whack. Okay, and this is pretty light work if as long as you follow the proper step. Good luck.